So yeah, we're gonna do all these examples. A lot of it is gonna spill over to the next class, so you can copy them down, take a picture, maybe leave spaces to write them down later. But before that being said, this is an E. But that being said, as I mentioned last time, there are problems here that we don't know how to do yet based on what I told you last week. Although there are also many that we would know how to deal with based on what we did last week. So you should at least be able to identify those, which are like problem 4, 6, 7, 8, problem 12, problem 14, problems 11 and 17, technically you could use what we did last week to do those, but you wouldn't want to. It's gonna be a lot harder than what you'd want to do. So we are going to learn how to actually do the rest of these. From 13 you can also do at this point. But before that, we have to deal with a couple of issues here. So one concern is, as in problem 1, you'll notice that you have sort of this situation here. You have two functions being multiplied together, and you want to know how would you go about differentiating that. Now, one guess, which is a very typical and reasonable guess for someone who doesn't really have any much experience with calculus, would guess, well, just differentiate that, and differentiate this and multiply them together. And that is, of course, the wrong guess. That's actually incorrect. You can't differentiate two things, stick them together, and that's the derivative of the product. Here's an example for how you know that's not going to work. For example, if I were to take the derivative of x times x, and I was like, okay, I know how to differentiate x, that'll give me 1. Derivative of x is 1. Multiply them together, you get 1 as the answer, but we know 1 isn't the answer, because that x times x is x squared, and by now we know that the derivative of x squared is 2x. So clearly that approach is incorrect. What is the correct approach? So there is something that we call the product rule. So this was on the bonus for the quiz. So it is a rule that tells us how to differentiate products. So basically, it says that if I have two functions, f of x and g of x, and they are multiplying each other, how would I find the derivative? Does anyone actually know the product rule? Yeah.
Is it the first f of x times the derivative of g of x plus g of x times the derivative of f of x?
Right. You take the derivative of one function at a time, and then you add all of these guys together. So you can differentiate the f and leave the g, and then plus you leave the f and differentiate the g. This is called the product rule. And just so you know, because of course I'm going to ask you to write this down in another quiz at some point, it's acceptable not to write the of x part. Sometimes that can just be annoying. So you could express this as the derivative of fg is f prime g plus fg prime. That's the product rule. That tells us how to deal with the product of two functions. If I want to find the derivative, how do I actually go about doing that? Now, you might wonder, well, why is that? Nope, wasn't wondering. Okay. You might wonder why is that. So if I have like some function that is f of x times g of x, and I want to find y prime, I know that we have a definition for what that means. That's the limit as h approaches 0 of the function evaluated at x plus h minus the function evaluated at x all over h Now at this point, what we do to figure out the answer is we do that sneaky thing that math people often do, is to either add or subtract something convenient or multiply and divide by something convenient. That simplifies things. And in this case, the trick is to actually subtract f of x times g of x plus h, and then add f of x times g of x plus h. Right? So I'm adding 0, not really changing the value of anything, but this is going to be surprisingly convenient. We have f of x g of x all over h, and here what we can do is in the first two terms, my g of x plus h is a common term. I can factor that off. So this is f of x plus h minus f of x. When we put the g of x plus h factored off to the back. Plus, in these two terms, the f of x is the common term. I can factor off the f of x plus h. I'd be left with g of x plus h minus g of x. And of course, this is all over h. But of course, it's a fraction. We can split a fraction across the denominator. So what we do is we split up these h's here. So that's why it has two pieces to it. And now you'll start to notice some things. Limits distribute across sums, and it also distributes across products. So the limit of this part is going to be the limit of this part times the limit of that. And the limit of this part is going to be the limit of this part times the limit of that. Because we know the limit definition of the derivative, we recognize that is just f prime. Now as h approaches 0, g of x plus h is just going to approach g of x because you plug in h equals 0. Here this is going to be f of x times, and this of course you'd recognize is the derivative of g. So that's kind of where the rule comes from. By using the limit definition, we figured it out. Similarly, the derivative of one function divided by another function is not obvious. So again, you can't just differentiate the top and differentiate the bottom and think that's going to be the answer. There's also a formula like this, a process that you'd have to go through to figure out a division. And here, using the above, namely the product rule and the chain rule, which we spoke about last week, you can actually figure out a rule here without going through the limit definition. If you wanted to differentiate f divided by g, what you would do is you would think of this as f times g to the minus 1. And then you'd apply the product rule. Right? So applying the product rule here, that's differentiate this one, leave that one alone. Plus, you leave the first one, times differentiating this one. Now what you're going to realize is that in g to the minus 1, g is the inside function. Raising to the minus 1 power is the outer function. And you remember the chain rule says to differentiate something like that, you differentiate the outer function, which would be that from the product rule, and then from the power rule, and then multiply by the derivative of the inner function. So that's what that derivative is going to look like. So here we're using the chain rule. And now you can simplify. So here we have f prime over g minus, here we're going to have fg prime over g squared. What we can do is create a common denominator. So we're all over g squared, and so we'd have f prime g minus fg prime all over g squared. And that leads to another rule that we called the quotient rule, because the result of a division is called a quotient. So this is how we differentiate quotients. So this basically says the derivative of one function divided by another function is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And this is something that we know now. This is called the quotient rule. It's how you differentiate a division of functions. Now at this point I told you a bunch of rules, and as always, whenever I give you a bunch of rules, you should have a very special place in your hearts and of course in your notebook where you put all the rules together. So some important rules at a glance. You really want to have the rules separate and all that, and just have them all in one spot. Help keep things organized. It'll be easier for you to learn and absorb them, as well as have it as some sort of reference. So, some basic rules that we've looked at is, notice one was the power rule. So, what does the power rule say? It's one thing you have to write down the quiz today. Yeah?
It's n times x to n minus 1. So the derivative of
The derivative of, it starts with that.
x to the n,
X to the n is
nx to n minus 1.
That was the power rule. We also know how to differentiate e to some power, which is? Yeah?
The derivative of u times e.
Right. The power times the derivative function. We also learned how to differentiate the natural log of something. Yeah?
It's 1 over whatever's in the natural log, so like 1 over u times the derivative of u.
Right. C prime over u. We also learned at this point now, we can add to these the product rule. We also learned the chain rule last week, so that you should know how to write down. What does the chain rule say? So that's how we differentiate composite functions. So that's differentiating something that looks like f of g of x. So it's like you take the g and you plug it into the function f. What does that look like? Yeah?
It's the derivative of the outside function times inside function times the derivative of the inside function.
Well, it's not times, it's evaluated at the inside function. So the inside function leaves it there and you multiply it by the derivative of the inside. Right. And now we know the product rule. So this says to differentiate a product of functions is that, and we know the quotient rule. So differentiate a division of functions. It's that. Now, order doesn't matter for the product rule, but it does matter for the quotient rule because there's a subtraction here. You have to subtract the right one. So it's very important that you take the derivative of the top times the bottom and then minus the top times the derivative of the bottom. If you do it the other way, it's wrong, right? So the order actually matters here. Yeah, those are just some of the important derivative rules that we have so far. The power rule, the exponential rule, the log rule, chain rule, product rule, quotient rule. These are going to be the guys that is going to help us figure out all these guys and to differentiate all sorts of functions. So that being said, let's actually get through some of these. Let's look at one. So we have y is equal to x cubed e to the x. How would we differentiate that? Yeah.
3x squared times e to the x
Okay.
plus x cubed times e to the x.
So what are you using here?
Product rule.
Product rule, right? So you look at that, you're supposed to recognize, okay, the x cubed, I recognize that guy, the e to the x, I recognize that guy, but they're multiplied together. So Here you have two functions being multiplied, f and g. Right? So then you want to always think, do I have a rule for that? And notice that it looks like this rule over here. So that means you're going to do the product rule. So I know to differentiate something that looks like f times g, the answer is going to be f prime times g plus f times g prime. And so this means that my y prime is going to look like f prime, which, as you said, the derivative of x cubed is 3x squared. How do we know that? I have a rule that tells me that. Right? So we apply the power rule there, we leave the g alone, plus the f, that's x cubed, times g prime. We want to differentiate e to the x. Well, how do we do that? Well, I have a rule for that. Differentiate the x, which is 1, and multiply by the original function. So that's just e to the x. And for something like this, that's fine for me. Technically, you could actually factor something out here, like x squared e to the x, and you'd be left with 3 plus x, something like that. But usually, you only have to factor if there's like a denominator where you might want to cancel something. Otherwise, you don't really want to have to factor here. So yeah, you would need the product rule here. Some students like going to the side and just writing everything out. Like they'll go to the side and be like, okay, f equals the x cubed, and I'm going to say g equals e to the x. So the f prime is going to be 3x squared, and the g prime is going to be e to the x. And then they just take those pieces and plug into the formula in the right positions. Right? So I'm going to have the f prime, put it here, times the g, put it here. Then I'm going to have the f, put it here, times the g prime, put it here. So some people like to set it out that way. It's fine if you do that. Just make sure you're using the right formula and you're plugging things in the right positions. 2. How'd you do that one? Well, that one's pretty much the same way anyway, right? That's just an excuse for me to make sure you remember how to differentiate the square root of x. But other than that, it's almost the same thing. This is the f, that's the g. You realize, oh, they're multiplication of two functions. The derivative is going to be f prime times g plus f times g prime. And so our y prime is going to be equal to, what's the derivative of square root of x?
1 over 2 radical x.
1 over 2 radical x times the g plus the square root of x times the g prime. Derivative of e to the x is e to the x. So that would be the answer here. Y equals 3x squared and x. What do you think we're going to do for that one? Yeah?
Well, you can either put the 3x squared to make it the exponent of x and the natural log of x, and then you can chain rule it, or you can just straight up go into the product rule.
Right, so to deal with the first suggestion, that one, it turns out that that is actually a little bit more complicated than we can actually handle right now. Because of course, if you take this as the u, you want to go with the derivative of this is going to be u prime over u. And how do you actually differentiate x to an x squared? We actually don't know at this moment. We know how to differentiate x to a constant. So in the power rule, it's important that you realize the power has to be a constant. There is a way to differentiate this, and I'm going to teach you, but we haven't learned yet. So the first suggestion isn't really going to get you very far at this point. So, and even after you learn that, it's still going to just be easy to just jump right back into the product rule. It's two things multiplying by each other. So it's going to be derivative of the first times the second plus first times derivative of the second. Eventually I'm going to stop writing down what I'm writing here in blue. It should become second nature after a while. So this means that your y prime is going to be the derivative of this, which power rule. 6x, we also know that constants factor out, so the 3 I can just stays while I differentiate the x squared, times the g is just ln of x, plus the f, which is the 3x squared, times the g prime, derivative of ln x,
1 over x.
1 over x. Right? Again, that's the u prime over u idea. This one here, you can do a nice little simplification by canceling the x's, and so this is 6x ln x plus 3x, and that's perfectly fine by me. You can factor out a 3x if you want, but I'd be okay if you didn't. So that would be that one. Ideas for this one, what would you do here? Yeah?
It would be radical x. Plus x times 1 over 2 radical x.
So you're applying the product rule here?
Yeah.
We'll get into this more next class, but we don't need the product rule here. Now, for reasons that I'll explain next class, whenever you don't really need the product rule, I'd rather you not use the product rule. There's another way to do this. Yeah.
You could change it to y equals x times x to the 1/2.
1/2, right? And then you just apply laws of exponents. So your y is just going to be x to the 3 over 2. And you can get away with finding y prime using the power rule. So this is just going to be a note for the future. Oftentimes you're going to realize that your life is going to be easier if you try to simplify before applying calculus rules. Try to get all the algebra out of the way before you actually get to the calculus. And in general, you're going to want to apply simpler techniques before more complicated ones. And I'm going to show you some situations where you can actually get in trouble by doing the product rule or the quotient rule, and you actually don't need to do them. The chain rule this doesn't apply to the chain rule, because the chain rule, you can use it literally all the time, and it's never going to really put you in a disadvantageous position. The worst thing that can happen to the chain rule is you multiply by 1, which means what you did was useless, but it doesn't put you into a situation where you might get the problem wrong all of a sudden. There are times when students try to apply the product or the quotient rule, and they just get messy algebra, and they get it wrong. You definitely want to try to simplify before you use those last two rules.
If you apply the product rule, would you get a different answer?
You would get the same answer.
Same answer.
But I'm going to show you that students can often make mistakes on their way to that answer, where it's just not worth the risk. So the product and the quotient rule, they'll always work. It's just that in practice, actually trying to force them to work can get you in trouble. We'll talk more about that next time. So next time, complete these examples for tomorrow to see if you're really getting what to do here. And we'll pick up with those tomorrow.